All right, Math 8, here we go. We got our last lesson in the unit, lesson 9-5, volume of composite shapes. So in this one, we're going to just take all of our different formulas, and we're going to have what we call composite shapes, which is where there's like a shape that's made up of more than one shape. So we're either going to add different volumes together or we're going to subtract different volumes together. So this first one is the sum of two solids. And what it looks like I have here is on the bottom, I've got a cylinder, but on the top I have a cone. Okay, so for this one, I'm going to take the sum of the area of the cylinder and then the sum and add it to the area of the cone to get my total area. So we're going to say that the total volume is equal to the cylinder volume plus the cone volume. So the volume of the cylinder would be pi r squared times the height. So can't see the rest of the shape, but here's the bottom of it. It says the diameter is 16. That means that the radius is 8. Okay, so we're going to do pi r squared times the height. It looks like the height of the cylinder over here is 10. So this would be pi r squared, pi times 8 squared. That would be the base area of the circle that's on the bottom of the cylinder. And then I'm going to fill up the object with the height, which is 10. I almost wrote H. 10. There you go. All right, so that's going to be the volume of the cylinder. The volume of the cone is the same exact volume, except we use 1/3. So we're going to do 1/3. The base area is exactly the same because the cylinder has a circle on the bottom and a circle on the top. So it also has a radius of 8. But this one has over here, I can tell the height over there is 5. So we're going to do 1/3 of pi times 8 squared times the height of the cone, which is over here, it's 5. All right, so I'm just going to find these the two volumes of the cylinder and the cone, and then just add them together. So 8 squared, that's 64. 64 times 10, 640. So I've got 640 pi's. For the other one, I've got 64. When I do that, so 64 pi, that's the base area, and I'm going to multiply by 5, which would be half of this one, so that's going to be 320. So I've got plus 1/3 of 320. Sadly, 3 does not go into 320, so here's what I've got. I've got 640, oops, dang it, can't write today. 640 plus 320 over 3 pi. So that's what I'm going to put in my calculator, and that's going to give me my final answer. So I've got 640 pi plus, I'm going to write this as a fraction here, 320 divided by 3. I put it in parentheses because I want it to divide by 3. I guess the order of operations would have been fine there, but whatever. I'm just talking to myself at this point. All right, so here we go. There's the formula. I plugged in my calculator. The answer is approximately 2345.7 is what we're going to call it. So we're going to say our volume is approximately 2345. And then we're not going to round up, so we'll just say 0.7 meters cubed. If we wanted the exact answer, I'd get like a repeating decimal here, but it'd be possible. Like if I do 320 divided by 3, I get 106.6 repeating. See there, it's repeating. So what I could have done over here is I would have had 640 pi's plus 106.6 repeating pi's. And then since they're both being multiplied by pi, what I could have done is just added 640 plus 106 and gotten, what's that, 746.6 repeating pi. So that would have been my exact answer right there. On problems like these, we would probably usually give this decimal answer. It makes a lot more sense for the problem that we're working with. But this is the exact answer, 746.6 repeating pies. Whew. All right, next one. Now what we've got is we've got a cylinder with a hole cut out of the center. Now that hole is also going to be a cylinder. It's just going to be smaller than the cylinder that we are dealing with. So we're going to take the area of the big cylinder and then subtract out the volume of the small cylinder. So we're going to take the big cylinder and subtract the small cylinder from it. So we have the big cylinder, that's everything, but then there's a hole in it, so we're going to subtract that hole from it, which would be the smaller cylinder inside there. They're both going to have a height of 5. So it looks like the big cylinder has a diameter of 6, which means the radius would be 3. So we're going to do pi times the radius squared, and then times the height of 5. There's the big cylinder. We're going to subtract the small cylinder from it. Small cylinder has a radius of diameter 2, so the radius is 1. So for the small cylinder, we do pi times 1 squared times the height of 5. So over here we get 9 pi times 5, which is 45 pi. Over here we got 1 squared. So 1 pi times 5 is 5 pi. So if I've got 45 pies and I take away 5 pies, I've got 40 pies left. So 40 pi centimeters cubed would be my exact answer in terms of pi. And then I could just take out my calculator and do 40 times pi, and that comes out to 125.6. We're going to round that up to 7 because there's a 6 after the 6. So 125.7 centimeters cubed would be our final answer. So in this one, we had 2 shapes that we needed to add together. This one, there's a hole in the shape, so we needed to subtract it. All right, there's a couple of problems here that you can work on. It looks like this one is all prisms. This one you can kind of think of as either an addition or a subtraction. So if you're thinking addition, break it up into 2 prisms and then find the area for those. If you're thinking of it as subtraction, think of the whole prism and then you're cutting out this little section here. I personally would prefer addition on that one. And then over here, it looks like we got a hemisphere and a cone. So maybe this is like, what do you call it, a shaved ice or something like that. That's what it looks like to me. Anywho, all right, so if you want to try them out on your own. You can pause right now, and then you can watch me do it. So here we go. I'm going to do it. I'm going to do it. I got this. All right, so first thing that I would do on this shape is split up the 2 shapes. So the bottom shape has a height of 2, and then we've got a length and a width over here. So I'm going to do the big prism on the bottom, and then I'm going to add the small prism on top up here. Okay, so in a prism, we've got base area times the height. So here I can see the shape on the bottom is a rectangle. If you can use your imagination there. There's your imagination. All right, so this is the area of the base. So that would be 6 times 4. So the base area would be 6 times 4, and then we would multiply by the height. The height of this bottom one is over here. It's got a height of 2. So 6 times 4 times 2. Okay, this shape over here. It looks like this is 4, and this was 2. So this part is 2. This is also 2. So this one has a height of 2 centimeters. That's this section right here. And I found that because the whole thing's 4. This part was 2. So that leaves us to reason that this part up here would be the height. So I know the height of this one is also 2. Now I just have to find the base area. So they're giving me this part here. I need this part here because we're going to find the base, which is this rectangle on top. And I can get that number from right here, 4. So this section must also be 4. So the base area on the top is 3 times 4. And then the height right here is 2. So we got our big prism, 24 times 2, 48. Our small prism, 3 times 4, 12, times 2, 24. And so we end up with, what's that, 72? I think that is 72 centimeters cubed. Next one, we're going to take the cone plus the hemisphere. I can't spell. Yeah, there we go. Sorry. Okay, so the cone, we've got the base is the circle, so that's going to be pi r squared, but it's a cone, so we have to do 1/3. 1/3 pi r squared, r is 3, times the height, and the height is right here, it's 10. The hemisphere. Hemisphere is half of a circle, so this is going to be 2/3 pi r cubed to the 3rd power. Well, the r is the same r, same radius that we had for the cone, so it's going to be 3 to the 3rd power. Because remember, in spheres and hemispheres, we do the radius to the 3rd power. Okay, so for the cone, I've got 1/3. 3 squared is 9 times 10. 9 times 10, 90 pi. 1 times 90 is 90, and then I divide by 3. 9 divided by 3 is 30. So there's my volume of my cone. Now I'll do the work for the volume of the hemisphere. I've got 3 to the 3rd power. 3 times 3 times 3. That's 27. Okay, I'm multiplying by 2/3, so I multiply by 2. I get 54. And then I divide by 3. So I multiply by 2, and now I'm going to divide by 3. So 54 divided by 3 is, oh, that should be 18. Yeah, it's 18. Okay, and so 30 pi plus 18 pi, that's 48 pi. That is my total volume. And this would be in units of meters cubed. So it said write the exact answer with the units included. We have done that. It is 48 meters cubed. So we're just going to take our shapes, figure out what composition of other shapes are making it, and then we're either just going to add them together or subtract them if we want to. That's it. That's all I got. Math hard. See you guys later. Bye-bye.